Okay, here's the next part of the review. For some reason I skipped parts B, C, and D on the review. There is no such part, or no such parts. Also changed the recording settings, so hopefully, even though I'm still recording on an old computer, the audio is going to be a little bit better, which means you can say bye-bye to Batman the teacher. So here we are looking at piecewise functions with limits and continuity. And with these piecewise functions, you need to probably from the very beginning go ahead and identify what represents the left and what represents the right of our point in question, which in this problem is x approaching 2. Well, if x is less than 2, I'm going to go ahead and identify that as the left side of 2. If x is greater than 2, I'm going to go ahead and identify that as the right side of 2. So right. And then x equals 2 right here for number 5, or that x equals 2 here, that's just when x is 2. That doesn't include the left or the right for the middle there. Alright, so part A is what is the limit as x approaches 2 from the right? So this is the right side of 2, and the right side of 2 is represented by x plus 4. So I'm simply going to plug in 2 to the right side, which is going to be 2 plus 4, and that gives you a limit of 6 coming from the right. Okay, part B says limit as x approaches 2 from the left. Well, if I'm coming from the left side, now I have to look at the piece of the function that comes from the left. That's x squared plus 1. So I will plug in 2 into x squared, so 2 squared plus 1, and that gives me 5. So the limit as x approaches 2 from the left is 5. Then part C is the limit as x approaches 2. Now the biggest mistake people are going to make here is to look at the middle, because this is when x equals 2. But remember, the limit as you approach 2, if it doesn't specify a side, then part C, the answer only exists if the left and the right side both equal the same thing. So we have to look at both sides. And if both sides are the same, if the left and right are equal, then that's the answer to the limit as x approaches 2. Then this limit exists. Otherwise, this limit does not exist. Well, in parts A and B, we've already done the right and the left side, and we see that we got different answers. The right side is approaching 6, the left side is approaching 5. That means this limit does not exist. So since the limit as x approached 2 from the right of my function is not equal to the limit as x approached 2 from the left side of my function, then the limit as x approaches 2 overall from both sides does not exist. And that's our answer to part C. So I kind of wanted to flesh that out in great detail. A lot of people want to look at the middle, but the middle, this piece in the middle, has absolutely nothing to do with any of these limits. However, part D, where I say what is f of 2, now I want to know what's happening when x is equal to 2. And when x is equal to 2, my function is at 5. So our answer to part D is 5. Part E, is my function continuous? The answer is no, because a function is only continuous if the limit as x approaches 2 is equal to f of 2. So no, because the limit as x approaches 2 of my function is not equal to f of 2. The only way a function can be continuous is if the limit as you approach that number is equal to f of that number, and our answers to C and D were different. So that is number 10 all flushed out. 11 here, the same type problem. I'm not going to go into as great detail though. Number 11, I will go ahead and identify left and right sides. X is less than or equal to 3, that's the left side. If x is, actually that's just less than 3. If x is greater than or equal to 3, this is the right side. So that's the right side. And then part A, is x approaches negative 3 from the right. So this is a right side limit, which means I need to use this function for part A. So that's x minus 3. I'll plug in negative 3. Negative 3 minus 3 is negative 6. So there's our answer to part A. Part B is what is the limit as x approaches negative 3. Well, for part B, I'm going to have to come down here. I'm going to need more room for part B. For part B, I need to look at both sides. So I need to look at the left side and the right side, and since left and right are represented by different functions, then I'm going to have to look at them both separately. I've already done the right side, and I know the right side approaches negative 6, so now I have to look at the left side. So the left side of negative 3, the limit as x approaches negative 3 from the left of my function, I will use the equation x squared minus 9 over x plus 3. And let's see. So x squared minus 9, that will factor. I'll factor the top into x plus 3x minus 3. My bottom will stay x plus 3. X plus 3's cancel. And now from the left side, I can plug negative 3 into my x that's left over right here, and I get negative 3 minus 3, which is negative 6. So I know the answer to part B is negative 6. I'm sorry. That's the left-hand side is negative 6. So as x approaches negative 3 from the left is negative 6, but the right-hand side was also negative 6. So since my right side and my left side both equal negative 6, they are the same thing. That means this answer actually is negative 6 because left and right were the same. So because the left side equals the right side. The only way a limit exists is if both left and right sides agree, is what you call it in calculus, if they give you the same answer. Number C, the limit as x approaches 2. Well, let's see, where does 2 fall? Is 2 less than negative 3, or is 2 greater than negative 3? 2 is greater than or equal to negative 3. It falls under this spot right here in the bottom, so I will plug it into the bottom equation. 2 minus 3 is negative 1. G of negative 3 means I want to know exactly what's happening when x is equal to negative 3. And x equals negative 3, again, is this bottom one. It's x is greater than or equal to, so that includes the equal part. So I will plug in negative 3 to the bottom one. Negative 3 minus 3 is negative 6. And then the final question, is G continuous at x equals negative 3? And the answer is yes, G is continuous. Because I'll look up here and the limit as x approaches negative 3 and G of negative 3 are the same thing. So the answer is yes, because the limit as x approaches negative 3 of G of x, that answer was negative 6, and f of negative, or G of negative 3 equals the same thing. G of negative 3 also equals negative 6. If those two things are the same, then your function is continuous. Otherwise, your function is not continuous, and that's why number 10 for part E, the answer was no. The limit did not exist, but the function was 5. So those are not the same, so we said the function was not continuous. If the limit and the function have the same value, then the function is continuous. So there we go. I think that was it for this video. Yeah. Hopefully that wasn't too Batman-y.